Uh, Guys, am I audible to all? And I'm asking that, has anyone got anything for this question? Okay, yeah, I remember that. Okay, good. You did it. For finding the intersection, there can be many approaches. Okay, so the first approach can be, yeah, what will be the first approach? Yes, Kishan, you have done it. Can you tell me any of the approach that you applied?
Yep. So
Okay.
the approach which I followed is like uh, first we need to calculate the length of both the linked list, and like say for example for the first linked list it is 8 and for the second one it is 6. So in that case be maintaining a pointer for the second for the longer linked list, and it will be starting from the difference of both the length. Like it will be starting from the 2, and from that 2 we will be like uh, manually checking whether these are matching or not. At a specific point when it is matching, that is the intersection point of both the linked list. You got my thing?
Yep, I did got it. Any basic approach which we can follow?
Yeah, I was thinking that putting the hash code of both the linked list, sorry, putting the hash code of each of the linked list in a set, and then if the hash code matches, then we have an intersection. That's for the first part.
Right, like what Vishnu is saying, I'll just explain it to everyone. Like add all the addresses of any one of the linked list to a hash set. Okay, like I added all first linked list. Then when I'm traversing on the second linked list, I will keep on checking that if 6 is there in this particular set, if 8 is there. With 8, I don't mean the data, I mean the address of it. Okay, or if 3 is there, finally at 2 we will find out that okay, this address exists, and we will say that yes, we have our, like, the intersection is there. Okay, then finding the point of intersection, you already know you are at that particular node itself. Clear, everyone? Okay, so this is one of the, you can say, the approach to follow it. The next, which Kishan said, so always you can know that these linked lists, like since it has intersected at 2, there is a possibility it can intersect at 3 as well, right? Like there is a possibility it can intersect at this point as well, this point as well, right? Can it like intersect beyond this?
Ma'am, is the question that are they intersecting at multiple points?
No, no, no. The question is that right now you can see your linked list is intersecting at first, second, third, fourth point, right?
Yes, yes.
But there is a chances it can intersect at the third point or the second point or the first point. Yes. But can it intersect beyond this first point? Is there any possibility for that? No, right? You guys are able to follow me, right? Yes. Okay. So now, if it can intersect only up to this point, then this may intersect like at this point, it may intersect at this point, or it may intersect at this point. Can it intersect beyond this? Guys, are you able to follow me?
So beyond 4, no, but it can intersect at 7 or even 1, meaning it will just
Um,
be at a different point.
See, once it intersect, the last numbers are same for the both the linked list, right? Like 5. 5 is common for linked list 2, 5 is common for linked list 1, right?
Yes,
Yeah. That means that all the numbers in the last are going to be same for both the linked list.
yes.
Before that, what is the maximum possible place where your linked list can intersect?
Just 1. I mean, we are understanding that there is only one point of intersection. So
What I'm saying is, if 5 is common, okay, I'll take another pen. If 5 is common, okay, 5 is common over here, then we are checking if 2 is intersecting or not, right? Are you getting me? Yes. Let's suppose this 2 was not intersecting. Imagine your linked list look like 2 and 5, and just add this over here. Then there are 2 common numbers and your linked list is intersecting at 18. If this 8 will also be not there, let's suppose they're intersecting at the second most position, then it will look like this. If it is intersecting at the second position, are you able to follow? If it is intersecting at the first number itself, that means this is the same linked list, but here from H2 is also starting. Can it intersect beyond this?
I mean, yes, technically or theoretically it can.
How?
No,
Your
so
linked list length is finished. Your linked list length was only 5. Okay.
okay.
Okay. Your linked list length is finished. How it can intersect at -1?
No, I'm just imagining a case where
Okay, just tell me. You have one rod of length 8. You have another rod of length 5. And I am saying if they intersect at any point, let's suppose they are intersecting over this point, the remaining numbers after that are same. Okay, like the
yeah,
length or area, whatever is same.
yeah,
Okay. So if this area of the first linked list is 5, the area of this linked list is 5, then what can I say? That they're intersecting here, no? Will I
correct.
say that the half of the part of the rod is here and half of the part is here?
No,
No, right? Because we know that both the linked lists are ending up in null.
correct. Yeah,
Clear?
yeah,
So what Kishan's point is that if H1 is having certain length as 8, H2 is having the length as 5, then we know that for sure the starting 3 numbers are never going to intersect. Clear or not?
yeah.
Yes. So we skip these 3 numbers, that is H1 minus H2. Okay, up to these numbers, we just traverse and skip them. Okay, and after this point, we start matching. If at any point H1 is equal H2, then we say that intersection is happening. Otherwise, we say that intersection is not happening. Clear? Does it make sense?
Yes, madam.
Okay. Yeah, okay. So if you are clear now, can you try coding it up? Or should shall we try it together?
So one thing I still want to know, so we are just comparing the last 5 elements of both the linked list. Is that?
Basically, we are
Mhm.
comparing the minimum of the heights of both the linked list, like the numbers. Okay, like if the linked list is having the height as like length as 10, another linked list is having the length as 3. So what we will do, we are gonna skip 10 minus 3, that is 7 numbers of the bigger linked list, and we will only compare 3 numbers and the at the end. Clear?
So we are comparing just the address of the last 3 of
Yeah,
both the
like
lists.
last numbers or last addresses of the smaller linked list.
Yeah, got it. Yeah,
Okay.
yeah, it looks simple now.
Yeah, looks simple, but like getting the logic is the tricky part. Okay. How many of you have not got the logic? Anyone in the class who has not got the logic and all? Okay, great. Everyone has got it then. Okay, you can try as homework. Anyone who like Kishan has already tried it. So let's quickly write the code for this and we'll see like what's the problem he's facing. And other than this, we will discuss more question that you can take as an homework. Okay. Add to numbers. Has anyone opened the tab and saw that whether the code was shared or only the empty file?
Yeah, it was very good. It was very nice. I ran it.
Okay.
But one question I had was like when I was doing the reverse debugging, then a lot of extra data was generated in the debug. So it was almost like twice the number of nodes it was generated, but I can take it offline.
Yeah, like I told you that whatever my code is, it is generating extra space. So see how you can optimize it. Everyone,
Yeah.
are you able to see my Eclipse screen?
No, 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 no.
Okay. So we'll just copy and paste our singly linked list function. But here, like I can write the code for this, but it will be like everyone will be having the different addresses because like I am making 2 different linked lists. Okay, so that code in the hacker rank or in the lead code, it will be set in that way that you will be getting a correct answer. So Kishan, can you share your code? It will be helpful for me to like check it. Acha, you have shared it. Wait, let me see. Okay, share it in the group. Are you sharing? Yeah, HackerRank code, which was failing, and okay. Are you guys doing the questions on the HackerRank? Ashok IT HackerRank, Lead Code, Interview Bit, every place. Others, you can share your update so far. Let me see. Guys, it's a good thing that almost 8 people have stayed in the batch so far, like linked list, and now we are gonna go to trees, then we'll go to DP and graph. So maintain your consistency because it's really good to see that. Okay, and it will be really good for me as well at the end of the batch if you guys like whatever purpose you have for whatever purpose you have joined this particular course, if it's get fulfilled. Okay, fine. Like if you are not able to find it, Kishan, as of now, it's fine. You can just like find it later and then tell me. That will be fine. Then only like everyone else, you just try to do it today on some platform, and then if you're not able to do, then reach out to me. Okay, then that's great. We'll discuss another question. You have been given a linked list, which is like so it's basically like it's a self loop in a linked list. You need to check first condition if there exists a self loop. This is the last question in this series. Next of linked list. Then we will move on to, yeah, now would you, okay, after this, we'll move to trees first, and then in the between, we will move on to the miscellaneous questions. Okay, I hope that will be fine for you all. Okay, and then you need to break this, like the link which is making the self loop. So you have to disconnect. the link which is forming the self loop. Okay. Okay. So will you guys like to try this question on your own? This is an interesting question. So you can try it on your own, or if you want, I can just directly discuss it right now. You can try. Okay. So you can take it as an homework. We can discuss it tomorrow. Okay. Everyone is fine with that? Is there anyone who wants some more hint on this question?
I'm just thinking, how will I approach this? Is will again put the entire linked list in a set and then see if the hash code is matching or not, if it contains the same value or not. And if it is, then we will assign the later one which comes in the last as null. Well, like, this is the approach I was thinking. But if it is
Sorry, I
wrong,
didn't get your approach. Can you come again?
yeah. So my thought process was traverse from one until the last element in the linked list, and
But the thing
putting,
is, Vishnu, that once you start from one and like try to reach to the last node, you won't be getting any last node. You can see the self loop is there, right? If you
yeah,
keep on doing head dot next all the time, it will keep you revolving in that circle. Okay. So you won't be exiting that circle ever. And that indicates that you have a self loop. Clear?
right.
And that we need to figure it out.
Okay. So again, I'm changing my approach. So as I am traversing, I am putting it in the set condition in a hash set,
Mhm.
looking for the same hash code. And as soon as it matches, that time I know that it's going for a self loop. And that time I assign that next to null.
Correct. Like you are saying that you will keep on adding the addresses to your hash set. And once it like checks that this particular address is already there, you know that this loop exists, and whatever current node you are in, from there onwards, you will break the chain, right?
Yeah, assign it
Yeah,
to null.
it's a perfect solution. It will work out. Now, that is a space consuming solution, right?
Yeah.
Like hash set you will do, it will consume space. Now think of a solution which do not occupy any extra space. It can be brute force. It can take more time, but it should not take any space. Getting me? Hash set solution will work. Like you can make it work.
Okay.
Hash set solution. Complexity of that, I can tell you what it will be. As Vishnu said, one by one we will add the addresses. It will take n time. Okay. And then you know that from where to break. So only n time will be needed and space will also be n. As okay. You can
Yeah.
check it out. You can go back, check it out, Kishan, and then come back tomorrow. Yes, Vishnu, are you saying something?
Yeah. So if I understand the space problem with this is that it will take twice the space, one of linked list, one of hash set.
See, linked list is provided in your question. So whatever is provided in your question, you need not consider it in your space complexity.
Okay. Okay.
Okay. Yeah. So you just all go and try this solution and yeah, come back with solutions tomorrow. Then we'll discuss this. Okay, everyone clear? Okay. Okay, then the class was short, but I wanted to have the class so that the punctuality is maintained. So yeah, we'll have the class tomorrow. Yeah.
Ma'am, just once again, please share this whiteboard link. I know you have shared it, but once again, please.
Yeah, okay, fine.
Thank you, ma'am. I'll do this one.
Okay then, so I'll see you all tomorrow. Bye bye and have a nice day. Tomorrow's tree topic, no, day after tomorrow will be the tree topic. Okay, thank you guys.